In this video, we're going to look at the summary of the index laws. So I'll try to keep this as brief as possible and just get through the laws as quickly as I can. But at the same time, I don't want to skip certain important bits of detail. So let's have a look at law number one. So law number one states that if we have two terms, or more than two terms, but two terms with the same base, okay, we add the indices. So if you had a to the power of m times a to the power of n, we add the indices. So let's have a look at an example of that. And I might just, actually I'll just use a different pronumeral. So if we had, for example, x squared times x cubed, okay, that's equal to x to the 5. Now the question is, why is that? In fact, let's have a look at a sort of I wouldn't say it's a proof, but just a demonstration as to why x squared times x cubed is equal to x to the 5. Let's call it a proof, for want of a better word, I guess. It's not really a proof because we're only just looking at an example. Okay, x squared is just x times x. X cubed is x times x times x. We've got 5 of them, so x times x times x times x times x is x to the 5. Okay, index law number 2. Okay, is very similar to index law number 1. When you're multiplying two terms with the same base, you add the indices. When we're dividing two terms with the same base, we subtract the indices. So a to the m divided by a to the n, which is really just the same as a to the m over a to the n, which is just a to the m minus n. All right. And we can look at an example of that. So for example, if I had 8 to the power of 5 over 8 squared is just 8 to the power of 5 minus 2, which is just 8 cubed. Okay, all right, index law number 3. This is what we call the power to a power law. So a to the power of m, okay, if that is raised to the power of n, so it's basically a power raised to another power that you multiply the two indices together. Okay, so it becomes a to the power of m times n, or mn. So let's have a look at an example of this one. Okay, and I don't know, let's say again, let's say x cubed to the power of 4. Some students make the mistake of adding these indices together. Most certainly not. Okay, it's x to the power of 12. Why is that? Let's have a look at a quick proof. Okay, expand the brackets. So in other words, what does x cubed to the power of 4 mean? That means that this x cubed, this object x cubed, a good way to think of it. Think of this as an object. This x cubed is being multiplied to itself 4 times. So that's the same as saying x cubed times x cubed times x cubed times x cubed. And by law number 1, when you're multiplying terms with the same base, you add the indices. So 3 plus 3 plus 3 plus 3 is equal to 12. Okay, so that's index law number 3. So this is the power to a power law. Of course, there are variations of index law 3 where you can have multiple terms inside the brackets. I'm not going to go through those in this video. I may do some examples later on in a subsequent video, but just for now, we're just going through the basics of the index laws. Okay, let's have a look at the 4th index law, which is what we call the zero index law. Okay, so let me just adjust this board. So number 4. Okay, if we have a to the power of 0, right, so any base, but the base can't be 0 though. A to the power of 0 is equal to 1. Okay, but a itself is not allowed to equal 0. That's very important. Many times, and there's many times when I've seen the index laws, sometimes this is omitted. This a not equal to 0. Of course, a base of 0 kind of doesn't make any sense anyway. But I think it's very important to note that a cannot equal 0. Okay, it can be anything else, but just can't equal 0. You try 0 to the power of 0 in your calculator, see what happens. Okay, I think your calculator would be very happy with that. So as an example, okay, and I might do a couple of examples here. If we had say 2,000 to the power of 0, again put that in your calculator. Of course, you're going to get 1. Let's say you had 3x to the power of 0. Okay, that's not 1. It's going to be 3 times x to the 0, okay, which is really just 3 times 1, which is really just 3. Okay, so just be careful with these sort of examples. If we had 3x in brackets to the power of 0, that's 1. Okay, so two very similar looking examples, but very very different answers. Okay, question is, why can't a be 0? What about I guess a good question. 0 to the power of 0. Why doesn't this work? There's a good explanation for that. You may want to have a look at index law number 2, okay, to guide you as to the reason why 0 to the power of 0 gives you a math error. Okay, because then the calculator doesn't like it very much. Okay, let's have a look at index law number 5. Okay, index law number 5 is what we call the negative index law. So if you, for example, a to the power of negative n, so the index is a negative, that doesn't mean that the value is a negative. The entire value is negative. The index is negative, but that negative means something. It means reciprocal. That just means 1 over a to the power of n. Let's have a look at an example. Okay, so if we had, for example, 3 to the power of negative 2, okay, that's not a negative number, that just means it's a fraction. That just means 1 over 3 squared, which is just 1 over 9, of course. Okay, let's have a look at something a little bit different. A slightly different example to this, a bit of a twist to this one. What about if we had, say, 2x to the negative 3? Okay, that's the same as 2 times x to the negative 3. Notice that the 2 has nothing to do with the negative 3 at all, okay, which is just 2 times, now x to the negative 3 is a fraction, it's a reciprocal. It's 1 over x to the 3, and because we're multiplying the whole number to a fraction, it's actually the whole number multiplies the numerator, and that's equal to 2 over x to the 3. Now, what happens if we had 2x in brackets to the negative 3? What happens there? Okay, the whole bracket becomes a denominator. In other words, the reciprocal is applied to the entire bracket. I'll just move that board up a little bit. We get 1 on 2x all cubed. Okay, and we can expand that using index law number 3, the power to a power law. So that's really 1 over 2 cubed is 8. X cubed is just x cubed, and that would be the answer to this example there. Okay, now we have our last index law, and there is actually one other one that I want to have a look at as well, but it's sort of like an extension to one of the other laws that we've looked at. Let me just adjust that board there. Okay, so we have what we call the fractional index laws. So if we had, say, x to the power of 1 on n, for example. Okay, so I'm using a different base of x. I know I was using a's, with all the other examples, but it doesn't matter what the base is. X to the power of 1 on n. Now that really is it's like it's a root of that number. So that's what we call the nth root, okay, of x. So let's have a look at some examples of this. So if we had, for example, a to the power of half, okay, when the n is a 2 here. Okay, sorry, I'll just adjust that board just a little bit lower there. Sorry about that. All right, so a to the power of half really is the square root of a. Okay, if we had, for example, 9 to the power of half is really just the square root of 9, which is, of course, 3. Okay, let's say 64 to the power of 1/3. Okay, is just the cube root. Okay, so that 1/3 really means the cube root. Okay, the 3 is the value here of the what root it is. So whether it's a square root or a cube root, that's really the cube root of 64. Okay, which of course is just 4. 4 times 4 times 4 will give you 64. Okay, so and that we can enter in on our calculator. There is a button on your calculator for that to be able to enter in nth roots, so we could have 64 to the power of 1/4 or 1/5 or anything like that. So in fact, the key for that, just quickly, the key for that is just above the power key. Okay, so I'll just go a little bit closer there. So that's if you press shift and the power key, you can see there, you see the root, and you can put the what type of root it is, whether it's a cube root, you know, fourth root, fifth root, whatever. Okay, so that's that. All right. Now there is one other rule, so I might just, it's kind of an extension of one of the other previous rules that we've looked at. But let's say you had two things being multiplied together, but two terms, but the bases are different. So let's say you had a to the power of m times b to the power of m. Now, if the indices are identical, in fact, this is really just sort of the converse of the power to power law. So that's law number 3, if you remember that. So I'll just quickly go back to that. Sorry, it's sort of, the ink's sort of rubbing off there. That's this law here, if you recall that one. Okay, so that's really looking at that. The bases are different, but if the indices are the same, it's almost like you can factorize out the m. So that's really the same as saying a times b all to the power of m. Okay, this is not really a separate rule in itself, but it really is a sort of an extension of, again, that power to a power law, which is just a b to the power of m. So if you start off with ab to the power of m, it becomes a to the power of m times b to the power of m. But starting off this way, this is just law number 3 backwards. It is actually another very, very useful rule. So as an example, again, I'm using that rule back to front. If we had, say, 2 cubed times 5 cubed is really just 10 cubed. Okay, because it's just this, really just the same as 2 times 5, right? All cubed, which is again just 10 cubed. Okay, and if you don't believe me, 2 cubed is 8, 5 cubed is 125, 8 times 125 is 1000, which is 10 cubed, so that certainly works.